Okay, question number 8. It is given that b is equal to y to the 4 and the following differential equation with y cubed d2y over dx squared plus 3y squared times dy by dx to the square plus y cubed dy by dx plus y to the 4 is equal to e to the minus 2x. Part A shows that d2v over dx squared plus dv dx plus 4v is equal to 4e to the minus 2x. Second part of the question, find y in terms of x. Find y in terms of x given that x is equal to 0, y is equal to 1, and dy by dx is equal to negative 3 over 8. So how do we go about and show that this differential equation can be reduced to this differential equation? Now we're given that v is equal to y to the 4, so I'm going to differentiate this first. So I've got then dv over dx is equal to 4y cubed dy by dx. So now I've got my 4y cubed dy by dx. So in other words, what we're saying that this is equal to, is the same as y cubed dy by dx is equal to 1 over 4 if we divide by 4 on both sides, dv over dx. The reason I do this is because this y cubed dy by dx is the same as here, this y cubed dy by dx. This can be substituted later on. And then I can differentiate my first derivative again, get a second derivative, and now this is going to be my u, and this is v. So I'm going to be using the product rule over here. All right, so u, 4y to the cube, dy by dx, we differentiate to get d2y over dx squared, plus v, and my v is dy by dx, times the derivative of 4y cubed, which is then 12y to the square, and dy by dx times this dy by dx becomes dy by dx to the square. Now, if I were to interchange this, I can see a y cube here. Y cube due to y over dx square. Okay, so y cube, all right, d2y over dx to the square is equal to d2v over dx square, okay, and minus the 12y square dy by dx to the square. And I must remember there was a 4 here, so this 4 is here. So if we divide by 4 throughout the equation, this is going to get, this is going to disappear, and I can divide this by 4, I can divide this one by 4, and get 3y square dy by dx to the square. So now, then again, I can try and actually, I got my 4y cubed d2y by dx square here. All right, so what about this one here? Y cubed d2y by dx square. Okay, so if I were to do this, y cubed, all right, so here, I can say y cubed d2y by dx square, which is then there, this one here. So this is then 1/4 d2v over dx square minus the 3y square dy by dx to the square, okay, and then plus the 3y square dy by dx, all of that to the square, plus the y cubed dy by dx, and the y cubed dy by dx is this one here, which is 1/4 dv over dx, so plus 1/4 dv over dx, okay, plus the y to the 4 is given as v, so plus v, then all of that is equal to e to the minus 2x, that's the left hand side. Immediately this is going to cancel out with this one here. So I'm left with d2v over dx square, okay, minus this 1/4 here, okay, and plus 1/4 again, dv over dx, okay, plus the v is equal to e to the minus 2x. Both sides can be multiplied by 4. So if I do this, I'm going to get d2v over dx to the square plus dv over dx, okay, plus 4v is equal to 4e to the minus 2x. That has been shown. Here we are. So the first part of the question is done. This is question number 8, part A of the question. So this is exactly the same as this. So this is our first part of the question. Okay, now for the second part of the question, we are given the following condition that x is equal to 0, y is equal to 1, and dy by dx is equal to minus 3 over 8. And they're saying that we need to solve this differential equation here. Now, if we were to solve this differential equation, I'm going to equate, so let's write this down over here. This is the same equation. All right, so here we go. So what I'm going to do is I'm going to equate the left-hand side to 0. So let the left-hand side is equal to 0. So then this left-hand side over here, we can have an auxiliary equation, and that's going to be m squared, all right, plus m plus 4 is equal to 0. Now, if I were to solve this, I'm going to get m plus half. Okay, we can complete the squares. All right, plus the 4 minus the half to the square is equal to 0. So m is going to lead to 4 minus 1/4 is 15 over 4. So I got then m plus half to the square is equal to negative 15 over 4. And so m plus half. So I can say m is equal to negative half plus or minus, okay, plus or minus root of 15 over 2, because there's a minus here. All right, root of 15 over 2i. So we got some complex roots over here. So the complementary function, CF, can be written as e to the, let's say e to the alpha x, okay. So is into a cos beta x plus b sine beta x, where alpha and beta are minus half and root of 15 over 2. So we are saying that this is going to be e to the minus half x, sorry, into a cos beta is 15, root of 15 over 2, okay, then plus b sine of root of 15 over 2x, basically. Right, so here is my complementary function. And now if I have to find a particular integral, what's going to be my particular integral? Because the right-hand side is e to the minus 2x. So we can try, okay, let, well, I'm going to say then v, okay, is equal to e to the, not v because this is y, isn't it? So here is 4. Okay, we're looking for this one, for this differential equation here. So yeah, so v is all right. So v is equal to, if I were to try something, I'm going to try, let's say, k e to the minus 2x. And now if I differentiate this, I'm going to get dv over dx is equal to negative 2k e to the minus 2x. And you find the second derivative, so this is going to lead to d2v over dx squared, which is then 4k e to the minus 2x. I'm going to take this, all right, those two, plus, where's this thing? Yeah, plus the v into my differential equation. So I'm going to take all those values and replace it here in the differential equation. So d2v over dx squared, which is this one here, so I've got then 4k e to the minus 2x, okay, plus dv by dx, and dv by dx is minus 2ke minus 2k e to the minus 2x plus 4 times v, okay, and v is, we did say v is k e to the 2x to the minus 2x is equal to the right hand side, which is then 4 e to the minus 2x. And if we were to simplify this, 4 plus 4 is 8, minus 2 is 6, and I got 6ke to the minus 2x is equal to 4e to the minus 2x. My e to the minus 2x, e to the minus 2x can go. So I'm left with k is equal to 4 divided by 6, which is then 2 over 3. And so my particular integral is going to be equal to then v is equal to, what's my particular integral? And we did say it was k e to the minus 2x, where k is just found to be 2/3 e to the minus 2x. So that's my particular integral. Now, having found the particular integral, so what we can do now, we can try and find the general solution, which is basically made up of the particular integral add up to the complementary function. So my general solution is the particular integral, the complementary function plus the particular integral. Okay. The complementary function is here, this one. So we've got then general solution v is equal to e to the minus half x into a cos of root 15 over 2x plus b sine root of 15 over 2 times x. And then plus the complementary function, plus the particular integral. So plus here 2/3, all right, e to the minus 2x. Now that's my general solution. So where do we go from here now? What I can do is I can try and find a if I want. I can use the fact that x is equal to 0 and y is equal to 1. And because we know that v is y to the 4, so this can be substituted now for y to the 4. And y to the 4, y is 1, so 1 is equal to e. X is 0, so e to the 0, a cos of x, x is 0 again, so cos of 0 plus b sine of 0, and this is going to end up as 0, okay? And then we have plus 2/3 e to the 0. So we have 1 is equal to e to the 0 is 1 times a times 1, okay, plus 2/3. So are we saying then that a is equal to 1 minus 2/3, and my value of a turns out to be 1/3. Right, so now how do we go about and find the value of b in this case? So I'm going to differentiate the whole expression. So I'm going to differentiate from here. So let me find this, if I were to differentiate this, I'm going to get 4y to the cube dy by dx, because only then I can use dy by dx, which has been given in the question as over here, minus 3 over 8. Okay, so is equal to, I'm going to be using now the product rule because this is my u and this whole thing is my v. So u, which is e to the minus half x, into, if I differentiate everything inside here, I'm going to get minus root of 15 over 2 times a minus y, because cos, the derivative of cos is some negative sign, so negative sign. Okay, and then I've got, sorry about that, okay, root of 15 over 2 times x, sine, okay, times x. All right. Now again, I want to differentiate this one here. So if I differentiate sine, I get cos, and I got plus a root of 15 over 2 cos of root of 15 over 2x. Okay, and of course, I mustn't forget to put the b there. Okay, so cos of a root of 15 over 2x. Right, so this is uv plus v du. All right, so u dv is been, okay, so I've differentiated this. I've differentiated this. So now v, which is the whole thing, that is, I'm going to say, let me just put the plus over here, plus, sorry, v du, now u dv plus v du. So v is a cos root of 15 over 2x plus b sine root of 15 over 2x, differentiating now I'm going to differentiate e to the minus half x. So this is going to give me minus half e to the minus half x. Okay, plus, all right, now I'm going to differentiate this one here. So this is going to become 2 times, if I differentiate the 2x, I'm going to get 2 times plus 2/3 going to become 4/3. So I get minus 4/3 e to the minus 2x. Now here is my derivative. What are we going to do now? We're going to use the initial values that's been given in the question. So we know that a is 1/3 here, and we're going to substitute x for 0 and y for 1. So if I substitute y for 1, I'm going to get 4 times 1 to the cube times dy by dx, which is minus 3 over 8, okay, is equal to sorry, e to the 0, because x is 0. All right, and then I have minus root of 15 over 2a sine of 0, because x is 0 again. So this is going to turn to 0, plus root of 15 over 2b cos of 0, okay, all of that, minus, okay, my half, then e to the 0 into a, then we have cos of 0, so a times cos of 0, because x is 0, and then plus b sine of 0 plus b sine of 0, okay, minus the 4/3 e to the 2x, so minus 4/3 e to the 0, and we know e to the 0 is 1. So this here becomes minus 3 over 2, because the 4 can cross out with this, becomes 2. And then I've got my e to the 0, which is 1. Well, this one turns out to be 0, because sine of 0 is 0, cos of 0 is 1. So I have plus into root of 15b, root of 15 over 2 times b times 1. So this is basically 1, all right? Okay, so now minus, this here is going to turn into minus half. Okay, cos this is 1, okay, cos 0 is 1. So I've got a is 1/3. I can substitute a for 1/3. So inside I've got 1/3 times 1. Okay, plus this sine of 0 becomes 0. So plus 0, okay, minus 4/3 times 1, because this is e to the 0 is 1. So what we have here is minus 3 over 2, okay, is equal to root of 15 over 2 times b, okay, minus 1 over 6. Okay, this is 1 over 6, minus 4 over 3 is basically 8 over 6. Okay, so minus 8 over 6. So what am I saying is that the root of 15 over 2 times my b is equal to minus 3 over 2, which is 9 over 6. So I've got then minus 9 over 6. And if I were to say minus 1 minus 8 is minus 9 over 6. Okay, so and then we send it on the other side, becomes plus 9 over 6. So this turns out to be 0. So b is equal to 0 times the 2 and divided by the root of 15. So I got my b as 0. Right, so b is 0 and a was found to be 1/3. So now I can substitute these values and find my general solution for this differential equation. Okay, but because we are also told to find the differential equation in terms in terms of x. So what I'm going to do is I'm going to look here. I've got 4y cubed, all right, and let me just think. All right, so my general solution was actually this. Y to the 4 is equal to all of that. So I got then y to the 4 is equal to e to the negative half x into a, and a is 1/3, or 1/3 cos of a root of 15 over 2. Okay, so root of 15 over 2 x. This b is 0, okay, then plus I also got 2/3 e to the minus 2x. Now this is y to the 4 is equal to all of that. And so what am I saying? I'm saying that this 1/3 can be distributed. This can be distributed inside. So I got 1/3 e to the minus half x cos of a root of 15 over 2x, okay, plus 2/3 e to the minus 2x, and this is y. But because we have to find it y in terms of x, so the 4 can be, the power 4 can go on the other side, becomes 1/4, or the 4th root of all of that. So this is my final solution for this differential equation. I hope you've been able to get the most of it. This was quite a lengthy question, question number 8, coming from the October 2023 paper, and code 9231 further maths 22. That is paper 2. Take care. Thank you for your attention.